Hello and welcome to our solutions to the April 28th assessment battery. So once again, the topics are sorted in the order of most to least popular. So if you're skimming ahead to look for the answer to the one you're looking for, you will be able to get to it a little bit faster. So written response number 1, we're dealing with measurement 4. This is our trigonometry outcome. A 5.0 meter ladder leans against a vertical wall. The foot of the ladder is 1.7 meters from the base of the wall. We need to draw the ladder, the wall, and a triangle you can use to find the angle. So, let me enter in. Sorry, I didn't have this ready. April 28th solutions. All right. So, for this one, let's have our tools here. So we have a horizontal line for the floor, vertical line for the wall. Now, let's make our ladder a little bit thicker in a different color. Oh, sorry, I wasn't trying to zoom. Okay, and now I do need to zoom out to figure, oh, that's where our diagram is. My apologies. Okay, so now our thicker line for the ladder, that'll be up something like this. Now, labeling it, we have a 5.0 meter ladder. That's getting thick and hard to read. Let's go back to the fine tip. So our ladder is 5.0 meters long. We are 1.7 meters from the wall at the base. And we're asked for an angle theta. So our angle curve makes contact with the side we know. That makes this the adjacent side. It does not make contact with the opposite side. The longest side is the hypotenuse. That one we know as well. So in our SOHCAHTOA mnemonic, the cosine of theta is the adjacent over the hypotenuse. That's the one that's going to be useful. In fact, theta will be the inverse cos of 1.7 meters over 5.0 meters. The meters will cancel. We don't have to enter them in the calculator. I'm just putting them there because it's critical that we make sure when we have units that the units match. If you do the inverse cos of centimeters over meters, it's going to give you a very wrong answer if it can give you an answer at all. It's good to check to make sure we are in degree mode and not radian mode. So start by taking the inverse cos of 1. Or sorry, the inverse tan of 1. If you take the inverse tan of 1 and you get 45, you're good. If you get something else, it's probably pi over 4, and then you're in radian mode. If you get a third number, you're in gradians, which we don't deal with in Alberta's high schools at all. So cosine of 1.7 over 5 is about 70 degrees. Makes sense. If we look at the Pythagorean theorem, this side's going to be a lot more than 1.7. So that should be the longest, or the biggest side, outside from the 5.0. And this is our smallest angle. So here, see whiteboard, whatever we sketch, we should make it, mark it, because if we don't have something in that box, the teacher doesn't always have something flagging to mark. We are at 70.1 degrees. These connected problems. So we are given angle B and length B. Yay. So we need to completely solve the triangle. Angle A, given another angle, is the easiest one. 3 angles add up to 180. So if we take 180 minus our 90-degree angle, because it's a right angle, minus 53.5 for angle B, angle A is going to be 36.5. Now, ideally, we always go back to the original information in the question to solve for the rest. So a mistake in part A doesn't become mistakes in part B and part C and so on. Side A, that's going to be tan. Right? A is a short leg. We are given a short leg. We are not given the hypotenuse. So this is opposite over adjacent. So in other words, the tan of angle B is side B over side A, which makes side A side B over the tan of B. So our side B is 58.1. So that's 58.1 units over the tan of 53.5 degrees. 58.1 divided by the tan of 53.5 works out to 42.99173.846. So to the nearest tenth, that works out to 43.0. When it's asking for the nearest tenth, even if it's 0.0, you still have to put in the 0.0. If you just do 43, the computer scored system will not recognize it. It's an excellent habit to get into in Math 10 because in Science 10, you're going to do a lot with significant digits. It's really going to matter. Finally, side C. Again, we want to go back to side B and angle B. You can use the Pythagorean theorem if you want to double check it now that we have A and B. We could take the square root of our answer squared plus our 58.1 squared. And it gives us about 72.3. But again, if we made a mistake coming up with angle A and we use it for side B, that's going to mess us up. So instead, let's take the fact that we have the adjacent and we're looking for the hypotenuse and say, that's a cosine problem. So our hypotenuse is the adjacent over the cosine of theta. So 58.1 over the cosine of 53.5 running it through the calculator. Okay, I'm getting a very different answer from what I got with the from what I got with the Pythagorean theorem. Let me just double check these. Okay, the problem is entirely me. We're not given the adjacent side. We are given the opposite side. So that whole thing about going back to the original information only works if you use it properly. So this is also not the adjacent. That is the opposite. So 58.1 divided by the sine at 53.5. That is a match. Actually, in the display on my calculator, I've got 10 digits on my Casio, and it's a perfect fit for what we had with Pythagorean theorem, 72.27654928. So that was a case of me not noticing that, which I should have tweaked to earlier because we used the cosine for the other part, and I'd like to try and use the different trig functions if possible. All right. Okay, moving on to our next most popular in alphabetical order, it's measurement 3. So we have a paper straw. It's 18 centimeters long. So this, and it's shaped like a cylinder, so we don't have to guess. It's not a bendy straw. This is just a straight up paper straw. So that's like a cylinder where you've cut a smaller cylinder out of the middle. The radius from the center to the outside is 0.4 centimeters, and the straw is 0.1 centimeters wide. So in other words, if we're looking at our cross section, looking at it from above, we'll have two straws, or two radii. So there's the inside radius, and there's the outside radius. So the radius from the center to the outside specifically tells us which one that is. That is 0.4 centimeters. And the straw is 0.1 centimeters wide, so it's 0.3 centimeters here. Okay, and our straw itself, if we draw it as a cylinder, we should hopefully do better than that, but that's 18.0 centimeters long. Okay, so what is the volume of liquid that the straw can contain? Well, that's a cylinder of that inner radius, the 0.3 centimeters. So V is pi r squared h. It's pi 0.3 centimeters squared, 18.0 centimeters. Okay. So pi times 0.3 centimeters squared times 18. So the inner volume getting us 5.0893800099. That's our volume. And it is in cubic centimeters. We're asked to answer the nearest tenth. That's 5.1. Total volume of the liquid contained and the straw. Well, that we can just go to the outer radius. So that's the inner volume. The outer volume is going to be the same formula, but with 0.4 instead of 0.3. So that is 9.047786842 cubic centimeters. Yep, it's almost half straw at that point, even though it's only a quarter of the radius. It's almost half of the volume. So this one is 9.0 to the nearest tenth. The volume of the straw alone is what we get when we subtract our first answer from the second. So that works out to 4.0. It's 3.958406743 just by using copy and paste. Total surface area. This one I think is going to be tricky. We have the outer surface. We also have the inner surface, and we have the rings on the top and bottom. So the outside, that's like a rectangle where one side is 2 pi r when we unravel it. So slice it down the middle, unfold it, times the height. Our outer radius is 0.4 centimeters and our height is 18 centimeters. So we have 2 pi times 0.4 times 18, which is 45.238933421. The inside, same formula, but with 0.3 for the radius instead of 0.4. So that is a 33.929200066. The top and bottom. So we have what we call two annular rings. Coming back up here, there's one circle with a smaller circle removed. So each of them is the circle, the size of the outer circle, minus the radius of the inner circle. We cannot take 0.4 minus 0.3, subtract it, and then square it. This isn't going to be pi times 0.1 squared. So it's because we are squaring them first, and that is not a linear relation. Okay, so pi times 0.4 squared plus pi times 0.3 squared. Oh, I added when I should have subtracted. Pi times 0.4 squared minus pi times 0.3 squared. So each of top and bottom is about 0.219911485. Okay, we have two of those, one for the top and one for the bottom, just to drive the point home. If we did pi times 0.1 squared, we would have had 0.0314. It would have been 1% of pi. So it's about a seventh of what we actually got. Because 0.4 squared minus 0.3 squared is the same as 0.16 minus 0.09. So that's 0.07, not 0.01. So we have to deal with the exponents first. It's order of operations, even though there's often instincts to the rest. Anyway, so the total volume, it's going to be the sums of these three numbers. So we have the outside plus the inside plus the top plus the bottom. So going back and using the calculator's built-in copy and paste feature to make sure I don't make typos when I'm doing all of that, I come up with a total volume of 79.6079574 cubic centimeters. Coming up to the nearest tenth is a 79.6. All right. And next, we have a sphere with a diameter of 12 centimeters. What's the sphere's surface area? Well, the surface area is 4 pi r squared. R here is 6, not 12. The diameter is 12. The radius is half of the diameter. So 4 times pi times 6 squared is the same as 144 pi, or 452.3893421, but that's to the nearest square centimeter. So there we go. All right. Moving on to relations and functions 6. Given the standard form of the linear equation, ax plus by equals c, write expressions for the slope, the x-intercept, and the y-intercept in terms of a, b, and c. So we have no numbers here. We don't need them. We're asked for the general expression. So if we have ax plus by equals c, that's not a good looking c. All right. If we want the slope, let's isolate y and put this into y equals mx plus b form. So by is negative ax plus c, which says y is a negative a over b times x plus c over b. We now have two of our answers. So our slope is a negative a over b. I use the fraction keyboard command instead of the menu, but there we go. Our y-intercept we can read off in our slope-intercept form and see that it is c over b. So our y-intercept takes place when x is 0 And our y-coordinate is c over b. The x-intercept is what we get when y is 0. So if we come back here, when y is 0, we get ax equals c, which happens when x equals c over a. So there's our x-intercept, c over a and 0. And yes, we do have bracket menus and fraction menus. Our fraction isn't a menu, it's just a straight fraction. We can do it that way. I am used to doing it with keyboard commands. All right, here. So, looking at this form, we want to find one equation expressed in 3 different ways. Okay? So, if we had this chart, where we had big, large, huge, small, tiny, puny, hot, blazing, sweltering, well, we're looking for synonyms. Big, large, and huge are synonyms. So 1, 2, 3 would be correct. Small, tiny, puny, 4, 5, 6 would be correct. Hot, blazing, sweltering, 7, 8, 9 would be correct. So those are correct in this example chart, but that's just here to figure out how to write it. That's not the case up here. We will, however, have 3 options. So the first one has a slope of 2. We notice form A, these are all slope-intercept form. B are all slope point. C are all general form. If we look at this, options 1 and 6 both have a slope of 2. They're the only ones in their columns that have a slope of 2. Same with 8. If we isolate y would equal 2x minus 3. Those are the only ones that have a slope of 2. So 1, 6, 8 is one of our solutions. You may also go with a slope of negative 3, which would be 2, 4, and 9. If we highlight in different colors, 1, 6, 8, and then there may or may not be a third option, but we'll check. Yeah, slope's 7. So these are the only options here. Now I picked it matching the slope. You may or may not use them all in a format of this type. So it's always good to double check that the points we have here are on the same line. So going from form A to form C is just rearranging terms. You can track the sign changes, see that those match. Point B, for example, this has the point 6, negative 11 on the line. If x equals 6, 6 times negative 8 is negative 18, plus 7 makes negative 11. That's a point on the line. So yes, here we have these 3. All right. Now here, I'm going to turn our annotations off again. Express this equation in slope-intercept form. And we have a slope point form. Y minus 3 equals negative 13 over 4 times x minus 4. Y minus 3 is negative 13 over 4 times x minus 4. So y minus 3 is negative 13 over 4x. And a negative 13 over 4 times a negative 4 becomes a positive, not 52, it would be 52 over 4, so that's a positive 13. The negatives cancel, as do the 4s. We add 3 to both sides, and y is negative 13 over 4x plus 16. So there we go. Y is negative slash fraction 13 over 4x plus 16. Okay, and this should wrap up relations and function 6. All right, moving into the batch of the next most popular skills. That's AN3. The value of x that makes 4 over 3 exponent negative x equal 27 over 64 true is. Okay, so we have 4 over 3 to the negative x is 27 over 64. If there is going to be a way to make this true, then 27 and 64 have to be written as exponents of 3 and 4. Well, 27 is 3 cubed, and 64 is 4 cubed. So that's one step. If we bring in the negative here, deal with the negative part of that exponent, we reciprocate. So we have 4 over 3. We might also notice these exponents match. So we're going to have to introduce a negative here because we reciprocated. Or, no, sorry, we didn't reciprocate on this side. We reciprocated the other side. Okay. So this is a 3 over 4 here. Because the exponents match, we bring the 3 out. So x would have to equal 3. If x equals 3, then 4 over 3 to the negative 3 would work. If you're not sure, you can always plug 4 over 3 to the negative 3 into your calculator, ask it to write it as a fraction, and see that it does come out as 27 over 64. So this exponent is 3. Our next written response, so this was worth 2 marks. Kenny simplified the expression x to the negative 2 y squared all to the negative 2 times x to the 6y cubed, but he made an error. Here is Kenny's work. So we want to identify Kenny's mistake and then correct it, the right solution with positive exponents. So identifying that Kenny's mistake is one of the 2 marks, correcting it is the other. So let's go step by step. Kenny seems to have brought the negative 2 in. We do that by multiplying exponents. So yes, the new exponent of x is 4. The new exponent of y is negative 4. That checks out. The others are unchanged. Step 1 is okay. Step 2. X to the 4 combines with x to the 6 to make x to the 10. Y to the negative 4 combines with y to the 3, but they don't make a negative 7. Negative 4 plus 3 is a negative 1. So the error in step 2 incorrectly combined the y terms, which means in step 2, yes, he should have had x to the 10, but that should have been y to the negative 1. Which simplifies with positive exponents to x to the 10 over just a simple y, not y to the 7. And here, this radical expressed as a power in simplest form. Well, the 3 stays in the numerator, the 7 in the root comes to the denominator, so that's d. There's nothing we can do to simplify it because 6 isn't the 7th root of anything. Now the value of this expression, 49 to the 1/2 is the square root of 49. That's 7. It really doesn't matter what's in the brackets because it's to the 0. And anything to the 0 is 1. 7 plus 1 is 8. This wraps up algebra number 3. All right, moving on to algebra number 5. So we want to factor these polynomials as completely as possible. So here we have a 2x squared minus x minus 15. The factors of 2 are 1 and 2. So we have 1 and 2 are the definite factors of 2. Now the 15, it could be 1 and 15 or 3 and 5. We're going to start with the 3 and 5. This is a negative sign. So we're going to have a mismatch in our signs. One of these has to be positive, one of them has to be negative. we have a -1 for our coefficient here. So the product with the negative factors has to be a little bit greater than the product with the positive factors. Actually, 1 unit greater. The way to do that is if we have 2 and 3 to make 6, and 1 and 5 to make 5. So the 2 would go here to multiply by the 3. The 3 has to be negative. And then the 5 goes there. This gives us our 2x squared plus 5 minus 6 for the -1x, and 5 times a -3 to make the -15. So there we go. 2 bracket first. And I just accidentally hit the reload button. Sorry. So 2x plus 5 and x minus 3. Okay. Sorry about that. Reloading. It's the occasional side effect of having a microphone cable by the keyboard. Our next term of factor, 6x squared plus 5x plus 1. So this means factors of 6. We either have 2, 3, 1, 1 or 1, 6, 1, 1. We need a cross term of 5. All of our signs are positive. And we have 6x squared plus 5x plus 1. Just going to draw a line here. All the signs are positive, so they have to match. We're not subtracting. We could get 5 by subtracting if we had the 6 times x minus 1 times 1. We're adding. So 3 plus 2. So we have a 2x plus 1 and a 3x plus 1. That will give us our proper combination. 2x plus 1. We have to have brackets around both. If we did not put brackets around the first, it would just be 1 times the bracket, and the 2x would not multiply the bracket. So both of our binomials absolutely positively must be in brackets. X squared plus 4x minus 21. And actually switch colors here to make it a little more clear. X squared plus 4x minus 21. So our factors here, we have 1 and 1 for sure. Here we either have 1 and 21 or 3 and 7. We know we have middle term of 4. So 3 and 7 seem like a more likely combination. I'm going to say 1 times 7. If we make that the positive, we'll get our plus 4, and the 3 will be the negative. That's how we get the different terms. 7 minus 3 gives us the right combination. So x plus 7 times x minus 3. 7 times a -3 is a -21. X times x is x squared. 7x minus 3x is a positive 4x. Okay. Okay. All right. Now our next one here. This seems to be the last one in the set. So this is actually worth double the rest. These are, the first ones are 1 mark each. The last must be worth 2, or something here must be worth 2. It is going to be the last one because we have a common factor we have to pull out first. We have 2x cubed plus 8x squared minus 90x. So 2x cubed plus 8x squared minus 90x. We start by pulling the 2x we have common to everything. That leaves us with x squared plus 4x minus 45. This is a lot more promising. Our lead term is 1, so we're just looking at factors of 45. We have a minus sign before the 45, so we are looking for 2 different signs. Factors of 45 that subtract to make 4. If they're only 4 apart, it's not 1 and 45, it's not 3 and 15, it's got to be 9 and 5. 9 times 5 is 45. We have to have different signs here. We have a plus 4, so the larger product has to be positive. That makes it a positive 9 and a negative 5. So it's 2x, x plus 9, x minus 5. So this concludes our coverage of AN5, multiplying out polynomials. So moving on to relations and functions 3, which is all about slopes. So here we have 4 points. We need to find the equation of the line connecting A and C. Well, for that, so we have 11, 18, and negative 17, negative 11. These are our points. So point A is 11, 18. Point C, negative 17, negative 11. Our slope we're going to need, let's do 18 and 11 first. That makes the negative 11 and negative 17 second. Gives us 29 over 28. Okay. So that is a slope. It does not specify the type of equation. That means we could choose whether it's slope-intercept, slope point. I am choosing the easiest one to deal with once we have the slope, and that is slope point form. So we just plug it straight in. So now, AC is going to be perpendicular to BD. So we need to find the value of K in the equation of line BD. So if AC has a slope of 29 over 28, the perpendicular line has to have a slope of negative 28 over 29. Okay. So again, for simplicity, I'm going to put the K we're trying to solve for first, because it's our y coordinate. So that point is negative 20 and K. Our other coordinates, 20 and negative 19. So 20 is our x, negative 19 is our y, and we know that this has to work out to negative 28 over 29. So this is a k plus 19 over negative 40. But that has to equal negative 28 over 29. Well, 29 is prime, so we're just going to multiply that negative 40 up. So k plus 19, on the left, we multiply by a negative 40. 28 times 40 would be 1,120 if I've done my mental math correctly, and that is over 29. So then K would be 1120 over 29 minus 19. Let's put it over a common denominator. Okay, so 19 times 29 is 551. So that is 569 over 29. Which does not appear to reduce. So we have K is 569 over 29. So now, which points in this graph are on the line y equals a negative 4x minus 6? So our y-intercept would be a negative 6, and it comes down 4 each time it goes right, which means if we go left from negative 6, it'll come up 1, 2, 3, 4. So V is a point on the line. Now, left 1, up 4. 1, 2, 3, 4. Says A is a point on the line. So A and V should be the only 2 points on our line. And this should wrap up Relations and Functions 3. Except it doesn't wrap up because this was 2 parts. We had to find the value of K and the equation of line BD. I hadn't done that. So our equation, again, slope-intercept form is, or slope point form is more convenient when it's not specified. Y minus 19 equals negative 28 over 29 times x, and it was 20 that went with that. All right, moving on to algebra and number 1. At the time of this writing, there are 1,025 unique species of Pokemon listed in the Pokedex. In the first generation of Pokemon, there were 151 species in the Pokedex. So first, what is the largest prime factor of 1,025? Okay, let's do a factor tree. So we have a factor of 5 in there. We have another factor of 5. 41 is prime. So 5 squared times 41 is the full prime factorization. 41 is definitely the biggest. Greatest common factor of 151 and 1,025. 151 is not a multiple of 5, nor is it a multiple of 41. 164 is the closest multiple of 41. So they are what we call relatively prime. They have no prime factors in common, so the greatest common factor is 1. That means the least common multiple is one of those rare cases where we can just multiply the 2 numbers together. Normally it's the product divided by the greatest common factor. If you don't recognize that they are relatively prime, well then, the approved calculators for this course would do these calculations and give you the same answers anyway. Multiple choice 4. If a number is a perfect square, what can be said about its square root? Well, it's always an integer. That's one thing we can say. Right? Is it always even? Well, it's not always even. Right? 9 is a perfect square. The square root is 3. Is it always prime? No, square root of 16 is 4. And 4 is not prime. So yes, we are looking for that always an integer. Now here, we are calculating a cube root. So the cube root of 4173281. Right, that one we can put straight in the calculator. So that concludes algebra and number 1. All right, moving on to algebra number 4, when we're multiplying polynomials. There's 5 here. All we have to do is grind them out. Now, x plus 6 all squared. We could do this through the product of perfect squares, or we could grind it out by hand. One thing to remember, this is the same as x plus 6 times x plus 6. Right? It's not just x squared plus 6 squared, so we're not going to have x squared plus 36. We're going to have x squared plus 6x plus another 6x plus 36, or x squared plus 12x plus 36. I will accept jumping straight to that last step because this is the product of perfect squares. So when in doubt, multiply the whole shebang. Now here we have an x plus 5 and an x plus 2. Again, multiplying it out, the first terms, and then we can take the x times 2 for 2x, 5 times x, and 5 times 2, which is x squared plus 7x plus 10. Here, x minus 8 times x plus 3. We have x times x minus 8x plus 3x minus 24, which is x squared minus 5x minus 24. Now this one, 3x times x squared plus 2. We just multiply the 3x in. That's 3x cubed plus 6x. And our last one. Again, we are doing a pretty straightforward calculation. 3x plus 1 times x plus 9. 3x squared plus 27x. And then we have our 1 times x and our 1 times 9. So we have 3x squared plus 28x plus 9. This wraps up algebra number 4. All right. So next in line is measurement 2. We want to convert 1.4 metric tons into US tons. Well, a US ton is 0.907 metric tons. So notice that the metric tons are the smaller number. To make it a bigger number, with 0.907 as our conversion, we have to divide. 1.4 divided by 0.907, specified to the nearest hundredth, is 1.54. So we have more US tons than metric tons. Next, 4 pounds into ounces. Well, 1 pound is 16 ounces. So 16 times 4 is 64, but again, nearest hundredth, so we add the 2 decimal places. Now, ounces to kilograms. We're given that 1 ounce is 28.35 grams. So 18 ounces times 28.35 gives us 510.3 grams. To make that kilograms, you have to divide by 1,000 because you have fewer kilograms than you do grams. So that's 0.510. Now convert 1.4 tons to grams. Well, 1 ton is 1,000 kilograms. And 1 kilogram is 1,000 grams. So 1 ton is 1,000,000 grams. If we have 1.4 of them, we should have 1.4 million. 1,400,000 to the nearest hundredth, 0.00. There we go. And 5,000 or 4,590 kilograms to tons. 1 ton is 1,000 kilograms. So we just divide by 1,000. But nearest hundredth, so we delete that extra 0. That wraps up measurement 2. Moving on, relations and functions 2. So what does the vertical line test determine about a function? So a relation is a function if every vertical line intersects the graph at least once. No, it is not a function if it intersects more than once. A is wrong. B, a relation is a function if a vertical line intersects the graph at more than one point. No, that's the way to rephrase the same wrong answer we had in A. A relation is a function if a vertical line intersects the graph at exactly one point. That is very subtle. A vertical line can pass the graph at exactly one point, but a different vertical line can hit it 5 times. So this is not, strictly speaking, enough to be considered a function. A relation is a function if no vertical line intersects the graph at more than one point. So D is the correct answer. C is incorrect for subtle reasons. Okay, a vertical line can intersect the graph at exactly one point, while other vertical lines intersect it more than once. That's the important distinction there. So which set of ordered pairs represents a function? Well, this would be one that does not have repeated inputs. Option A, 2 appears twice. It's not that. Option B, -4 appears twice. It's not that. Option C, we have 2 10s. Got to be option D. Multiple choice 7. What is the definition of a function in terms of inputs and outputs? A relation is a function if every output, we could probably stop reading right there because the restriction's on the inputs. Every output has at least one input? Not necessarily. The line y equals x is a function. Every output has exactly one input. A relation is a function if every input has exactly one output. That is the definition. Not at least one output. And it has nothing to do with how many outputs. Are in there. So it is B. Now, numerical response 21. You want to find 3 true statements and record their numbers in any order. All linear graphs are functions. This is false. You can have a vertical line, and a vertical line is not a function, but it is a linear graph. 2, the graph of y equals 4 is a function. That is true. That produces a horizontal line. If a line is rising to the right, the slope will be positive. Also true. The graph of x equals 4 is a function. No, that is a vertical line. All functions are relations. True. We hope 6 is false because we're out of boxes. All relations are functions. That is false. So remember, functions are a type of relations. It's like functions are apples and relations are fruit. All apples are fruit. Not all fruits are apples. What is the main difference between a relation and a function? So, a relation is a set of ordered pairs where each input... No, that's the definition of a function. A function is a special type of relation where each input has exactly one output. Yes, this is true. It's not necessarily a set of ordered pairs with no restrictions. Definitely not with no restrictions. And special type relation is a special type of function. That one is backwards. The function is the special relation. All right, 2/3 complete, and moving on to relations and functions 5. Which function has a finite domain? So which one of them has restrictions? Now, you can graph these if you want. So graphing C, that would be the unfamiliar one in terms of graphs. But the finite domain, the domain is the list of all possible inputs or all possible x values. That's our vertical line. D's entire domain is 3. That's 1 point. The finite range will be B. Similar reasoning, the range is the y values. This only has 1. And which function has both domain and range, including all real numbers? Well, now we're down to either A or C, because both include all reals. We should know that that's always true of our linear functions. If you're not sure about the quadratic, you can graph it on your calculator. You will see that this does have a minimum possible value. So while the domain is all real numbers, the range is not. So the range here is limited. That doesn't mean it's a finite range. It still goes up to infinity. It is x greater than or equal, or y greater than or equal to a certain point. So if we graph it, x squared minus 9x plus 4, so here's our graph. Here is our lowest point, that negative 16 over, or negative 16.25, or negative 65 over 4. So it's still infinite, because it goes up as far as we want. But it does not include all real numbers in the range. So now, what is the domain of this function? Remember, the domain is all the allowed x values. So we have a point at negative 5. I'm actually going to use the equation editor to make it look a little bit prettier. Again, sets go in the curly brackets. Negative 5, negative 4. Looks like each x value, or each integral x value up to 5 appears exactly once. We have 11 points. The range of this function. Okay, what y values are we allowed? Well, thankfully, we don't have to worry about putting them in order. We could if we want. We could say our lowest is at 1. Then we have 3 points at y equals 2. Nothing at y equals 3. 3 more at y equals 4. So we've accounted now for 7 of our 11 points. 1 more at 5, 1 more at 7, 1 at 8, and 1 at 9. 1, 2, 3, 4, 5, 6, 7 different values with 1, 2, 3, 4 repeats adds up to 11. This concludes relations and functions 5. So with relations and functions 5 done, we move on to 7. We are converting our equations. These are the 3 equations in this set. A linear relation passes through the points 5, negative 5, and is parallel to the line y minus 4 equals 7 times x plus 3. See here, points is plural. It should be singular. We want to write the equation in the specified form. So if it's parallel to the given line, our point we know is 5, negative 5. I'm just going to put the m here for now. So that's our slope point form where we know we have the right point. Now the slope. If it's parallel, it's the same. Now slope intercept form. There we have y plus 5. Let me just do it out this way. So we're starting with y plus 5 equals 7 times x minus 5. Let's multiply that 7 through the brackets. Now we subtract 5 from each side. And there's our slope-intercept form, 7x minus 40. So y equals 7x minus 40. Now our general form, we have to have 7 and y on the same side. No denominators. That part's already been accomplished. The coefficient of x has to be positive. So we're going to have a 7x minus y for sure. And we can either leave the minus 40 on that side. I will accept that. That is actually the general form of a conical equation. So that's the proper answer for general form. And standard would be equal to the 40. I will accept both. This concludes relations and functions 7. All right, continuing to relations and functions 8. For the linear function, f of x equals negative 7x plus 9, find f of negative 1 plus f of 8. Well, let's do this. We're going to have two numbers. And we have a negative 7x plus 9. So f of x is a negative 7x plus 9. So f of negative 1 is a negative 7 times negative 1 plus 9. 7 plus 9, which is 16. F of 8, I believe, was our other one. So we have a negative 7 times 8 is a negative 56. And that would be a negative 47. Negative 47 plus 16 we'd have a sum of negative 31. So given g of x is equal to this equation and the value of g of x is this, find x. Be careful, the x is at the tail end here. So this looks like y equals mx plus b form, but our slope is 23 over 4, not negative 35 over 4. So here we have, they really gave us y equals b plus mx. To solve for x, y minus b equals mx. X itself is y minus b over m. Our y value in this case is a negative 127 over 4. Our b is a negative 35 over 4, but we're subtracting it. So that becomes a positive 35 over 4. Our slope is 23 over 4. One of the things we can do, multiply top and bottom by 4. That makes this negative 127 plus 35 all over 23. That makes it a negative 92 over 23. Or negative 4. Okay, our next question will load soon. Here we go. What is the value of h of 0 when x is 0? Comes up to 3. Well, it is defined. It's not negative 3, it's not 0, but that's a horizontal line. It's the same 3 at every single point, so it's equal to the value we have somewhere else. Now here, write the equation 15x plus 8y equals 11 in function notation. So the first step for function notation is to isolate y. 15x plus 8y equals 11. 8y is a negative 15x plus 11. Y is negative 15 over 8x plus 11 over 8. Now we replace y with f of x. So that's a negative 15 over 8x plus 11 over 8. And that's it. We just have that as f of x equals negative fraction 15 over 8x plus another slash frac 11 over 8. Now, given this function, g of x equals ax plus 9, where g of negative 4 is 21, find the value of a. All right, so let us solve for a. So we have, sorry, that did not work well. G of x equals ax plus 9. And we know that g of negative 4 is 21. So solving for ax equals g of x minus 9. And solving for a, not for x. A is g of x minus 9 over x. And we have g of negative 4 equals 21. So the g part gets replaced with negative 21. The x gets replaced with negative 4. So 21 minus 9 is 12 over a negative 4. Gives us an a of negative 3. This concludes Relations and Functions 8 on function notation. All right, Relations and Functions 9, Systems of Linear Equations. So which graph represents the system of equations shown? So we have 3x minus y minus 1 is 0. So possibly the easiest way to do this is to convert both equations into our slope-intercept form. In this case, we get y is 3x minus 1. And then y equals 2, y plus 2x minus 4 is 0. Becomes y equals negative 2x plus 4. So we have these two now. So y equals 3x minus 1. And y equals negative 2x plus 4. So we have our equations. All of these seem to have our x and y axes going between plus and minus 5. Okay. So this is the kind of graph we're looking at. Our intersection is at 1, 2. And in fact, our negative slope is red when our positive is blue. So this is the graph we're looking for. That seems to be what we have here. The red line has y-intercepts at 4 and an x-intercept at 2. Our blue line has a y-intercept at negative 1, and it's got that 2, 1 intersection. So B is the combination that works. All right, Henry invested 5,102 different accounts. A paid 7% interest, B paid 13% interest. The total interest is $453. How much did Henry put in each? It says algebraically determine, so it's not just a matter of graphing. It means we need to see some algebra for full credit in this written response. So we know the amount in A and the amount in B were 5,100. And B, well, A was at 7%, B was at 13%, and those add up to $453. So let's start by multiplying this one by 100. That eliminates our decimals. Now 7 is less than 13, so if we can eliminate A, or substitute for A, if we do it by substitution, A is 5,000, not 15, 5,100 minus B. Okay. All right. Now, 7 times 5,100 minus 7b plus 13b is 45300. That gives us a 6b here. And if we subtract 35,700 from both sides, we end up with a 6 and 9. So 9,600. So for B, we divide that by 6. 6 goes into 9 once, goes into 36 6 times. So that would mean $1,600 in account B. And 5,100 minus 1,600 is 3,500 in account A. Okay. So it is always good to double check that. We could see that 1,600 plus 3,500 adds up to 5,100. If we have, sorry, if I write too quickly, the web-based whiteboard doesn't always keep up. We multiply these out. Well, this is going to be the same as 7 times 35. The two zeros cancel the two decimal places. So that's 35. So 245 on this one. Take care of the decimals in advance for our 13% interest. That's 18, carry the 1, 16, oh, not 228, 208, or 108. I was carrying, yes, I was right the first time. Carrying the 1 there is appropriate. And 208 and 245 does make our 453. So, yes, the amount in A is 3,500 and the amount in B is 1,600. Although, if they've got guaranteed interest rates, while you're splitting them or putting less, maybe there's a limit to how much you can put in account B, because if it's fixed interest, you know it's going to pay out better. So why not put it all there? Maybe there's a limit on B, or maybe that's the average after the fact. It was just a higher risk. Okay, two linear functions have two different slopes and the same x-intercept. Well, it can't have no solution, because if they have the same x-intercept, that's where they intersect. So we have a minimum of one solution. Nothing will have exactly two. The options are 0, 1, or infinitely many. So it's down now to one solution, infinitely many. The fact that they have different slopes means it can only be one. If they pass once, they keep going. This wraps up relations and functions 9. All right. Moving into the last curricular outcome assessed this time around, algebra and number 2. So check off all sets of numbers that each of the following numbers belong to. So on a paper test, you would just do the check boxes. Here, a negative square root of 169. Well, the square root of 169 is 13. So negative 13. It is neither natural nor whole because it is negative. It's an integer, which Alberta uses the capital I. We prefer the Z. You're going to see every point beyond that. That makes it rational, and every rational number is real. Our other one, 2.147825615 ... It continues with no discernible pattern. So that means it's a decimal that eliminates natural, whole, and integer. There's no discernible pattern. It's not terminating, it's not repeating. That means it's not rational. So this has to be irrational. Deport, okay. Looks like the overline command is not ported directly from LaTeX. Oh, it's bar that he's using, okay. So Q bar is one of the sets, and then everything we have here is real. So Q bar and R would be the sets here. All right. 2 marks, 1 for the first number, 1 for the second. Now, to which sets of numbers does this belong? It is an integer, whole, natural, and rational number. So, which are true and false? Pi is rational. No. 0.45 is irrational. No, that's 45 over 100. It's a terminating decimal. So that is rational. So that's false. Negative 4.5 repeating belongs to the set of integers. No, anything that doesn't have a 0 repeating after the decimal is not an integer. You shouldn't need decimals at all to represent integers exactly. And every irrational number is repeating and non-terminating. No. We are 4, 4, 4 here. Every one of these statements is false. All right, on a calculator, sometimes not all values can be shown. To which sets of number does this apply? There's no discernible pattern. There's 3 dots. That makes it irrational. And that should actually conclude the assessment. Let me just double check our last written response. Yep, it checks out. And there we go. That's that perfect score we're looking for.